So good morning, everybody. We are just waiting another minute or so as people sign in, and then we'll get started. As luck would have it, although the meetings tend to start directly on time, a lot of people are clicking on their computer to launch the meeting, which takes a few seconds for the interaction to connect and the network to bring them on board and then go through the intro. So as we wait for them, we'll get started momentarily, give a few more seconds, and then we'll kick it back out. And again, say good morning to everyone. We hope you are staying safe during this horrible pandemic. I'm Dave Ableman, Vice President of Operations for Protek. And together with Joel Mueller, who is the Cool Green Power CEO, we are facilitating an ongoing series of COOLcons. So thank you again for joining this pilot as we kick things forward. And welcome for joining. The agenda today will take approximately 4 hours, and it will be broken into 4 individual sessions, each one lasting approximately an hour. The sessions will include a presentation or a panel discussion for 50 minutes or so, and then we'll jump into the Q&A, and at the end, give everybody a 5 or 10 minute break before the next session begins. The first session, of course, will be from our keynote, and that will be going into the energy efficiency issues and how the industry has evolved with HVAC. We'll follow that up with a panel discussion on HVAC efficiency opportunities, specifically opportunities in New York. Then we'll have a panel discussion on the impact of preventative maintenance on efficiency and how maintenance is so critical to the HVAC world. We'll also then finally explore some emerging technology that has been developed that can dramatically improve energy efficiency of HVAC systems. During these sessions, we'll have some interactive polls. And for the polls, we'll just ask you to click on a button. You'll hit submit. We'll give you roughly 30 seconds to respond. And if everybody finishes quickly and we have all the results, we'll know, and we'll be able to click quickly over to the results. People take a little longer, we'll let them, but again, we're not going to go beyond 30 seconds. If you do have some questions, please type them into the chat, and we will get back to you with answers during the Q&A, or we will get back to you subsequently, depending upon how much time we have for the Q&A and how germane that particular question is to that session. At the end, we hope you'll stick around and provide a survey. The real thing here is we are most interested in delivering good value to the people who participate, and we want to make sure that we're doing that, and the only way to validate that is through these surveys. So we're offering to give as much as $100 to people who participate in the event surveys. So speaking of the poll questions, let's go ahead, and our first question is, which HVAC energy efficiency stakeholder group do you self-identify as? Would you consider yourself as an HVAC technician, like an installer, manufacturer's rep, perhaps you're in sales? Or are you a building owner, operator, or an energy manager? Perhaps you manage energy and sustainability or energy efficiency projects, or you're a project expediter, perhaps work with an ESCO, an energy efficiency consultant. Now, I know we have some people from the utilities who are participating. So let's go ahead and take 30 seconds, hit the radio button, submit it, and then we will present our results. I see that everybody's finishing this one up pretty quickly, so let's move forward. And it looks like we have an interesting mix today. We have roughly 29% of people who are in the HVAC technical installation sales space. Roughly 8%, a small percentage, are running the buildings. The people for the managers, 23%, that's pretty high. And most, looks like, are in the ESCO, energy efficiency consultancy, or project expediter space. Plus, we do have a few people I see from utilities, so that's fantastic. Poll question number 2. What would you guess? How many residential, non-residential DX air conditioning units do you believe are installed in all of New York State? Are there less than 300,000? Are there 300,000 to 400,000, 400,000 to 500,000, 500,000 to 600,000, more than 600,000? So go ahead and hit the radio button on your screen. And once that is completed, We'll have the results, and people seem to be taking a little more time thinking this one through. The other was easy. This is maybe a little more challenging. Now we've got enough people, and these are our results. It looks like a lot of people think there might be less than 300,000, and the next jump is actually between the 500 and 600. Everybody's in the middle is kind of just guessing as well, and then 14% roughly say more than 600,000. So surprisingly, it's actually closer to 700,000 in New York State. There are quite a few in New York, and that's why this is such a significant world that we are operating in. And we're looking forward to helping those who are managing all of those systems to improve their energy efficiency and to get the most out of their systems. At this point in time, I would like to turn our session over to the first speaker, Dennis Landsberg. Dennis has over 44 years diving deep into building energy efficiency, and Dr. Dennis Landsberg has chaired ASHRAE's National Technical Committee on Building Energy Systems. He's also been a lead author of ASHRAE's Energy Efficiency Guides for Existing Buildings, and he is one of only 65 people in the world who have ever been inducted into the Association Energy Engineers Hall of Fame. So we have a Hall of Famer with us. Today, Dr. Landsberg will share insights on how energy efficiency in the HVAC industry has evolved and where it is heading for the small commercial sector. So thank you. Dennis, take it away.
Good morning, everyone. I'm Dennis Landsberg, and I'd like to welcome you all this morning. I'm going to be talking about all the exciting things that are happening in HVAC efficiency, and this is a really exciting time to be an energy consultant. And right now, policy seems to be driving everything. There's a drive toward energy efficiency, and there's a drive toward eliminating carbon. And our goal is to have 50% renewable generation by 2030, and there's actually a 30-year plan to pretty much eliminate all fossil fuels in New York State over the next 30 years. So when you're dealing with the new building, you want to focus on net zero because it's a lost opportunity if you don't. And when you're dealing with existing buildings, which is our primary focus here, you have to take a little bit of a different approach. And existing buildings are important because there are 50 times more existing buildings than new buildings, and more than half of them are going to be here in the next 35 years, 35 years from now. So we're edging toward net zero. We're going to have to do it with at least half of the buildings that are still out there. And energy efficiency in commercial buildings is the nation's foremost low-cost climate strategy. Now, right now, the drive is to use solar and wind. We have a fair amount of hydro, but a problem with hydro is it damages the environment. It's endangering fish and whatnot. And so most of the focus has been on solar and wind. And when you increase solar energy use, if you look at the graph at the side here, you will notice that you have what's called the duck curve as you'll get more and more solar energy. The solar is active in the middle of the day, say noon to 4 p.m., and it actually causes a peak in energy use at the end of the day. And so in order to account for this, we have to use the batteries. Now, the other problem with net zero buildings, and the picture at the top is an early net zero building. Yeah, you'll notice it's a low-rise building and it's on a large site. And this is typically what you see. But most of our buildings are in the cities. And so the solutions for cities are not the same as net zero in a suburban area. And in fact, there's going to be more of a push toward having the solar in solar farms rather than being on buildings, because a net zero building with all the energy generation on the site is a building with a low population density, and it leads to more transportation costs. So there's a balancing act here. We have to look at the transportation issues as well as the environmental issues. If I could have the next slide, please. Now we're seeing a lot of more sophisticated systems in the environment, and I'm going to be focusing on some of the systems we're seeing in the smaller buildings because of the focus is on the smaller buildings. About 80% of the buildings in the United States are actually small buildings, and they're typically maintained by contractors, and architects and engineers don't go near them after they're built. And what we're seeing now in the Northeast is you're seeing a lot of variable refrigerant volume and a lot of geothermal heat pump systems. And this again is, we're trying to go to high efficiency, all electric buildings. Our heat recovery is important because we need outside air for a healthy environment, and this lowers the cost of actually reheating the air. And you're seeing more of a focus on zone dampers rather than just having one or two thermostats control the whole building for a zone dampers with individual thermostats and more sophisticated controls, so that way they can control each of the spaces more efficiently. We're also seeing a move toward natural refrigerants, and three of the ones I have mentioned are carbon dioxide, ammonia, and propylene. And again, the reason we're moving toward these is if you have a leak, it doesn't affect the environment anywhere near the current refrigerants. Now, when you're looking at cutting the energy cost of an existing building, there's a few things you want to focus on. The first is there's usually a lot of low cost or no cost items, and you're able to lower the cost rather quickly. You also want to focus on the time of a replacement of equipment. And the reason for that is if you have to replace a piece of equipment anyway for a little bit more money, you can get a more efficient piece of equipment. And so you're leveraging the opportunity cost of having to replace the piece of equipment anyway. Now, if you want to take advantage of this, you have to have a plan. It doesn't have to be a complicated plan, but you have to know that I have a packaged rooftop unit and it's not going to last more than 20 years. It's already 15 years old. It's going to fail at some point and I have to replace it. And if you look now to decide what your options are to replace it, you'll have a plan. If it fails without a plan, you're just going to grab the cheapest piece of equipment you can find, and it's a lost opportunity, and you're not going to save a whole lot of energy. And the other item we'll look at is this curve at the bottom. There's a sweet spot in the payback curve, and generally, the most energy efficient equipment has a very long payback. The cheapest equipment is terrible, but there's a sweet spot right at the knee of the curve where you get quite a bit of energy savings. And it's the most cost-effective place for you to be. The next slide, please. So this is what a full-scale energy plan looks like, and it looks kind of complicated, but it really doesn't have to be complicated for a small building. Basically, you want to set savings goals. You want to analyze the major systems in the building. do some cost estimating and figure out the most cost-effective thing to buy. And when you install something, track your energy bills and understand how your building is using energy, and then basically just repeat the process. Yeah, for smaller buildings, it's going to be a lot simpler than for larger buildings, but you always want to do the low cost items, and you always want to plan for equipment failure, because equipment failure is inevitable, and it's not a lot of work to do that. And if something major fails unexpectedly, you're out of business until you replace it. And that's it. I'd like to thank you for your time. And do you have any questions?
Thank you very much, Dennis. That was fantastic. Our next speaker is Jodi Smits-Anderson, the Director of Sustainability Programs for DASNY, New York State's public authority, which has been financing, designing, and building health and educational infrastructure in New York for over 75 years. A board member of the Northeast Sustainable Energy Association, she will share insights on how New York State policymakers are incentivizing the small commercial sector, including the creation of HVAC energy efficiency jobs. Take it away, Jodi.
Hello, everybody. My name is Jodi Smits-Anderson, and I'm the Director of Sustainability Programs for DASNY, which is a large New York State authority. What I'm going to talk about is just the challenge and the opportunity that lies in front of us. Some of you might be familiar with the BHAG designation, which is a big, hairy, audacious goal. And that's what we have. It's represented in New York State by the climate law, which is telling us, appropriately so, that we need to reduce greenhouse gas emissions 50% by 2030, and then a full 85% by 2050. So this is across all sectors of the state. This is not limited to just the building environment, but affects transportation and education and healthcare. It affects how we deliver goods and where our food has to come from. We have to rethink every system that we created based on fossil fuels and recreate it for the health and well-being of the people around us. Next slide, please. So our status currently is that we've been dealing with, as you all obviously know, COVID and situations that have brought equity to the forefront of our awareness. We have seen that the shutdown of the last 10 months or so has called into high relief all of the issues with our economy and how it's structured. And through all of this, we need to pay attention still to the fact that our climate is changing, and we need to be intentional about how we want it to change. We have an opportunity to do the right things with all of these concerns in mind. And that's what makes it a big, hairy, audacious goal. It means we have to invest a lot more thought and a lot more awareness into the decisions we make, because these are connected issues. We will make mistakes if we address our climate concerns without paying attention to equity or without paying attention to health or our economy. So we have to be smarter and more connected in our thought processes and more genuine about reaching out to other people for their insights in order to do the right things. Next slide, please. We have done exceptional work. DASNY, for example, is an institution that's over 75 years old. We started building residence halls for the state university system in New York. We have done that very, very well, and we should be proud of that work. And we also have to recognize that the circumstances around our built environment and around our communities has changed. The population is higher, the stresses on environmental systems are greater, and we are working in detriment if we don't figure out how to do things differently in order to achieve the goals we need to achieve. Energy efficiency is not enough. Again, energy efficiency with an understanding of how humans behave is an imperative. Energy efficiency while supporting health and well-being and connecting people to nature is an imperative. Energy efficiency while ensuring that access to renewable energy and renewable transportation and walkable communities is there for everyone is an imperative. So this is a big revelation. It's our revelation to share, to pick apart, and to work together to figure out. Next slide. So as a recap, we need innovation and we need connections. We need systems that work with nature, work with people, work with buildings. If there is a consultant out there or a contractor that thinks we're building buildings just to build buildings, they're missing the point. If there's anyone out there that thinks that buildings are to protect us from nature, they're missing the point. Interdependence is strength. When you're a child, you are dependent on your parents or the people raising you. And as you emerge into being a teen and a young adult, you staunchly defend your independence and you say, I can do this on my own. I am strong, I am capable. It's only with interdependence that comes with age and wisdom that you start to realize that no one person and no one building and no one community can do everything on their own, and no one system, that it is strength when you can rely on those other systems and build on those innovations and work with that information. So I encourage all of you attending this to pay attention to broadening the network that you've connected with, being curious, understanding that every single step is not only a step on the path and in the right direction, but a step that might reveal new answers. And that will give us the ability to innovate and to not be ashamed of things we may have done poorly, because the new information is going to help us to do better. Next slide. So my question to you is really, what will you bring to the work? And I have only listed a few things on this slide, and you can certainly read through as you like. There has to be much, much more than the few ideas I've put here. Your perspective is going to bring light and knowledge to the table. Your curiosity and your ability to talk with others is going to help you understand how to do what you know how to do better than you ever have in the past. So come to the table, bring your ideas, bring your curiosity and your willingness to iterate and to be iterative in the process, because there is so much more ahead of us. And I encourage you absolutely to bring all of you to the work. Thank you very much.
Thank you very much, Jodi. Greatly appreciate the insight. Was actually kind of impressed by using the term BHAG for those unfamiliar with it. Big, hairy, audacious goal is what it stands for, and it's one of the key of 7 aspects that were identified in a book called Good to Great that enable companies to become great. So if you want to read an interesting book, it's a great one to take a look at. Jodi, thanks for bringing that point up into the big HAG that you have identified for your organizations, which others should take on. Also appreciated the key that you pointed out regarding how when you save money, you should repurpose the dollars that you save for ongoing initiatives. Plus the point that you made regarding increasing education around the importance of going electric only and what that entails. All very good points. So again, thank you very much for your input. At this point, we are going to switch gears just slightly and start answering some of the audience questions, the pressing questions that the audience has for the keynote speakers. So Spence, please take it away.
Okay, so we have our first question, which is for Jodi, and it's from Richard. And Richard asks, cooling as a service is being deployed mostly offshore to address the maintenance issue. Could you go into a little about that?
Actually, I'm not familiar with cooling as a service in that approach, so I can't really go into detail on that. is there more information there that could help me with the bigger concept of that?
I will wait for a second, see if
Okay.
Richard puts in a comment in there. But while we're waiting, Dave, if you want to ask one of the other questions, please.
Well, actually, I should point out that you can buy cooling and heating as a service. There are a couple of companies in the US that will do that for you. So if you don't want to buy a chiller, you can pay by the month and they will install the cooling or
So
rooftop
lease.
units,
Okay.
and they'll maintain them and everything else.
I'm sorry, I didn't understand the term cooling as a service. So yeah, I don't know. Yeah, that's great, Dennis. Thank you. I wasn't aware of that term, but I think that that's a phenomenal approach because you then it's like having PV on your roof if it's owned by the power company. You can get a benefit from it, but the maintenance is on them, and likely, and this is from my perspective as an architect. And as somebody working just in general in facilities, likely the maintenance has a better chance of being done. And I think that that's a really important facet.
Excellent. You actually answered the question through that for Richard, so thank you very much for Dennis for chiming in for that. Dave, do you have any other questions?
Yes, there was a question that came in that is probably best for Dennis to answer. But Jodi, you should probably want to chime in as well. Due to COVID-19, many are stressing the importance of increasing outdoor air ventilation. While some say current standards are okay due to less people in the buildings, what do you see happening as it relates to optimizing energy and health concerns?
Well, what's happening in new buildings is we're seeing heat recovery ventilators, and that allows you to bring in a lot more air without spending as much money. And in fact, there's even heat recovery units now for homes where they mount on the wall and they give you a turnover of air. The COVID situation has opened our eyes to a lot of different things, and I don't think the only solution is going to be to kill bacteria inside the air handler. You're going to be seeing systems in the future that can kill viruses and bacteria in the space without harming the people. There's a number of ways of doing it, and you're about to see it happen. So just to point that out, you'll be seeing it evolve in the next couple of years. But as Jodi pointed out, human health is extremely important, and human productivity is extremely important. And we do hurt ourselves when we only focus on energy. For example, if you mount windows high on the wall, you get more daylighting. Except if you're building a school, the students need to see the horizon or their eyes don't develop. And so having the windows only high on the wall isn't really going to help you. So things are more complicated than they seem, and I do totally agree. You need an approach where you involve all the designers in coming up with effective solutions, and that is a lot harder to do in existing buildings.
Yeah, I think regarding ventilation and health, I would recommend looking into a couple of resources for anyone here who wants to know more. One is a special pilot aspect in the LEED rating system that informs on COVID and air quality in buildings specific to viral transfer. The other is in the WELL building standard. Also the same, they're really, the WELL building standard actually is entirely about wellness in the space, and they've focused on COVID and strategies in existing buildings and in new buildings to address COVID safety. I think that the key point is, in the question, it was talking about there's the ventilation being adequate because the occupancy is lower. I guess that I would suggest, especially in existing buildings, one of the things that we know as designers is that existing buildings often were built at a time when there were no ventilation requirements. So please be careful about making the assumption of any existing building that it's adequate, because we have gotten smarter. And as we get smarter, we know what screw ups we made in the past. So we should be very attentive to those. I think if there's a way to make sure the occupancy is low and that the ventilation is adequate and ramped up whenever the occupancy levels ramp up. And you can of course do that with CO2 sensors, or CO sensors as a read. That would be great to do. And ventilation certainly, filtration certainly, and also there are many emerging UV treatments that would be acceptable as well. All of these are going to take energy to do, and we just have to use the energy we need to use wisely and not waste and not allow more, more waste in our systems.
Thank you, Jodi. So while this topic is not really focused on IAQ, indoor air quality, that is a very important area going forward. And we do understand that while HVAC is not the only component, there are several initiatives afoot to help improve the airflow and to pick up the particles as they come into the air. For example, Jodi mentioned UVC, and make sure it's the C that's the important piece. It's not just UV. There's also some ionization technologies that are out there that are very compelling, as well as putting in some helpful agents into the airstream right at the HVAC units. For example, we're familiar with some probiotics that can help eliminate some of the bacterial issues within HVAC systems. Spencer, is there another question that you can bring up from the audience, please?
Yes, we have one more question before the break. Electrification of small commercial buildings is a growing strategy to reduce greenhouse gas emissions in New York State. What are the implications for HVAC energy efficiency, and where are the opportunities?
So I want to state a broad aspect of that, and I just mentioned it when we were prepping for this call. As we move to electric forms of heating and cooling, we just have to be aware, and we have to help our building occupants understand that if there's a system change, and that system change has a longer ramp up and a longer dissipation, the feedback loops are going to be longer. So it's not like, forced air, which is just horribly inefficient, but it's very fast. Once you use a forced air system, regardless of how that's heated or cooled, you're going to know when things change. But as we move to radiant systems that are really that help with electric heat pumps, all of these things have a longer rise and fall, and our occupants need to be informed about that so that they can participate and not undermine this system. Broad statement.
Exactly. If you have a hot air furnace, for example, you can heat the air to 180 degrees when it's cold out, whereas when you have a heat pump, you're maybe heating it to 110 or 115. So ideally, you want to do a radiant system and only be conditioning the ventilation air. And then you use a heat recovery system to reduce the amount of energy to even less. And again, that's harder to do in an existing building, although I can see it being beneficial in some of the older buildings. An issue we have in some of the older buildings is that the floor-to-floor height is not adequate for ductwork if you're going to do all the heating and cooling using air. And so, a classic example is the Empire State Building. They've had to put air handlers in closets because they don't have enough room to duct air and mount the units above the ceiling. So a combination system is what's going to happen going forward, and you're going to have anticipation because they can't react instantly. It's absolutely true. But on the other hand, if you have a lot of mass in the building, they won't necessarily have to react instantly.
Yeah, that's a great point. You build the buildings so that they actually support the energy systems as opposed to being a problem for the energy system to fix. That's great.
Oh, planning in advance. What a novel idea. So thank you again, Dr. Landsberg and Ms. Smits-Anderson. Our next session starts at 12 o'clock, which is in approximately 5 minutes. So for those of you who need a break, by all means, go take a couple of minutes. And the next session will be on HVAC energy efficiency opportunities for small commercial sector in New York State. We welcome you back in about 4 minutes. Thank you.